Alright, welcome to trigonometry. This is what it's going to look like. This should be on YouTube, and I hope that everybody's doing well. We are going to start this chapter out by talking about simple things that a lot of you have seen before, angles, degrees, and special triangles, okay? So, way back in geometry, for some of you that was 2-3 years ago, an angle was formed by two rays, okay? So, in trigonometry, it's going to be a very similar process, obviously, except everything's going to start at the positive x axis here. So if it's a positive angle, you're going to go from the x-axis on the positive side in a counterclockwise rotation. So basically you're going to be going up, and then a negative angle is going to be starting from that same spot, except you go down in a clockwise rotation, whatever the angle says. So we're going to be talking about a lot of different things. Initial means start, so the initial side is always going to be this x-axis positive side, okay? And the terminal side, if you think of terminal, a terminal at an airport is when you finally get to the gate to load. It's the ending spot, so negative. This other side is called our terminal side. So those are just a few vocabulary words that you're going to have. Angles, if you look at this slide, you guys should be able to know this. So right angles, I hope you think in 90 degrees, okay? Straight angles, just a straight line. How many degrees is that? 180 degrees. Acute angles, less than 90. And then obtuse angles would be greater than 90. Okay, so those angles, hopefully when I write those, you kind of can make those connections. Complementary and supplementary. Complementary is when the two angles sum is 90, and then the supplementary ones are when those two angles added together equals 180. So if I want you to give the complement, if I say give the complement, that just means the complementary angle. So I'm going to denote complement with a C. So how can you find the complement if the original angle is 42? Well, 90 minus 42 equals 48 degrees. Okay, so that's your complement. Alright, how about just supplement angle if the original one's 42? You can just go 180 minus 42 equals, what is that going to be? 138 degrees. That's the last time I'm actually going to show the math too. So part B says 105. Can you get a complementary angle so that when you add 105 and that other angle it gets to 90? Yes, you actually can use a negative angle. Okay? Because 105 plus what? If you go negative 15 degrees, that gets you to 90. So your complement angle is negative 15. You can have negative angles to make this work. And then the supplementary one, when you add 105 and 75. That's what you get. If it's just theta, okay, this is a little bit different. So this is in general, so you literally have to write the math that I showed you in part A. So the complementary would be 90 minus theta, and the supplementary would be 180 minus theta, not S. Alright, so that's how you write that in general terms if they throw just a theta at you. Okay, to earn credit today for your notes, I'm going to have you email me. So what I want you to do, part of this is a double-edged sword in case I want to email you something. Email me. It doesn't matter what you really say, something that you're excited about, scared about for this class. Just say hi, have a great day. I don't really care. But if you can email me, please. That way I have an email address for you, or the best email address to get a hold of you in case I need to email you at any time during the semester. So that is to earn credit for the notes today. Okay, Pythagorean theorem. You all should know how to do this as well, hopefully. A squared plus b squared equals c squared. I'm going to go right into the most difficult problem that you'll see using this. If I want to solve for s, just know that your hypotenuse is across. So this is your c. Okay? So I'm going to go and I'm going to say x squared plus x minus 1 squared equals 5 squared. And you need to solve all of this. Well, x squared is pretty easy, but how do you expand x minus 1 times x minus 1? We got to think FOIL. So for some of you, you're like, oh God, here we go again. Alright, so that's how you expand it. Now I combine the middle because it's actually going to be, if I expand this up here, You got your x squared, and then outside is minus 1x, inside is a minus 1x, and then negative 1 times negative 1 is a positive 1. And then the middle combines to your minus 2. Okay? So now I have that. What like terms can I combine? I'm going to combine my 2x squareds to be a 2x squared minus 2x, but then I want to subtract this 1 over. Okay? So now, how do I want to solve this? I shouldn't have done that. I actually want to bring this 24 back. So I'm going to go 2x squared minus 2x, because the only way to solve is if it's set equal to 0. So I'm going to subtract that 24 back. And what is in common of all three? You always want to look for that. The 2. Alright, and then if you FOIL this guy, or factor, not FOIL, we already did FOIL. X of 4 and a 3. I need a negative in the middle, so I want a negative 4 plus 3. So what does that end up being? X equals negative 3 and x equals 4. If you give me both those answers on a test, you get it wrong, because this is a side length. And side lengths literally can only be positive. So this negative 3 will not work. There's no such thing as a side length of negative 3. So keep that in mind as we go through those problems. Okay? Special triangles, right triangles, review from geometry. So hopefully you kind of remember this, but this is imperative. You need to know this. Okay? A 30, 60, 90 triangle. Alright, you're going to have what we call two legs. One's the short leg, one's the long leg, and then your hypotenuse. 1, 2, square root of 3 should ring a bell for you. Just know that the short leg, the 30 degree, whatever is across from it, is the short leg. That is what we have as the 1. The reason we have these variables is that that's the relationship that we're going to have, and I'll show an example of that. But if you can think 1, 2, square root of 3, that's what we need. And then the okay, sorry about that delay there. That was just a student that stopped in to ask a question. So the short leg is x. The long hypotenuse is twice as much as the short leg. And then the long leg is square root of 3 times as much as the short leg. Okay, whereas a 45, 45, 90, you have the two legs that will be exactly the same. And then the hypotenuse is going to be square root of 2 times more than those two legs. So here's an example. So if I give you a 30, 60, 90, and then I know that the short leg is 4. So you just got to decide how do you want to set this up. So if this is a 30 degree angle, this one has to be 60, this one's 90, and I know that my short leg is 4. Okay, so if I go back and I think of my triangle, oh, I probably should do it the same way. So if I have a 30, I know that that means it's 1, the hypotenuse is 2, this one's the square root of 3 times more. So if that is the case, the first thing I do is I make the long side. Okay, if I give them the short, the hypotenuse is twice as much. So 2 times the 4 is 8. So I know the long leg is 8. And then what is going to be this square root of 60, or square root of 60, the 60 degree side is going to be square root of 3 times more than the short. Well, that just means it's 4 times the square root of 3. So your 60 degree side, your long leg is 4 root 3. Your hypotenuse is 8. Alright, what if I have this? I said a 45, 45, 90. Alright, and the leg is 1/3. 1/3. What does that make the other side? Well, how did I know instantly? I guess I did this without thinking. The other side's the same because it's 1, 1 square root of 2. So whatever one leg is, the other leg has to be. And then the hypotenuse is square root of 2 times more. So 1 root 2 over 3. And no, you do not need to write the 1 there. It can be just root 2 over 3. Here's the fun one. So what happens if you do this? So 30 degrees, 60, 90, and I know the longest side. Now that means the side, not the hypotenuse, okay? So the longest side, which is the hypotenuse, is 5. Okay? So if that is the case, how do I get back? Now, if I'm giving you the hypotenuse, so the longest side is 5, the easiest one to get is the small one. Because if you refer back to down to here, to go from the longest or hypotenuse to the smallest one, it's half as much. From 2 to 1 is half. So you just need to cut it in half. So to go from 5 to the smallest side would be 5 over 2. Because if you're thinking you work backwards, twice times, this small side times 2 would get me back to 5. And then once you get your small side, it's pretty easy to get your longest leg, because you just multiply by the square root of 3. So it'll end up being 5 root 3 over 2. Okay? So that's how you can go about using your special triangles in a variety of ways. Okay, this is what we're going to do tomorrow. So this is going to be our assignment. I want you to maybe look through them. We're going to work together as a group in our classes, and I hope you all have a great day.